This lecture is the continuation of the grading process that we started in the last lecture. And again, that basically has three parts: the analysis, the concept, and the final. During the last lecture, we covered the analysis portion. And in this lecture, we're going to cover both the concept and the final. Quite frankly, the majority of this lecture is going to be on the concept because that is really the most important part of grading. The ability to create a concept, and to do that you're going to need to visualize the site. You're going to need to see basic landform patterns. You're going to have to learn how to sketch contour lines. And you're going to learn how to test the priority areas using spot elevations and percents of slope. We're going to take you through this process. This is a lecture you're probably going to want to watch a couple of times. So grading is really sculpting the land or carving the land. And it's very important when you're grading that you learn how to work in large increments, just like a wood sculptor. When a wood sculptor is going to make a piece of artwork, you generally start with some rough lines and a chainsaw. You're making some very coarse decisions in order to develop your concept. And like in wood carving, once the basic shape is determined, then you can start to refine the design. But until you get that basic shape started, you should not be working on detail. You do not want to start by figuring out the details of an ear or an eyebrow or even a hand. You want to start with the basic rough shapes. You want to do this in wood carving, obviously, but you need to learn to do it in shaping landforms. Only after you have the rough concept sketched out can you then start to work on the detail of a design. This is the exact same process that we want you guys to start to understand. You have to develop a concept. The concept is your safety net. It will save you a huge amount of frustration. The worst thing you can do is start out in detail, try to work everything out in detail all the way around, then you have to change it and you're frustrated. You spent 3 hours doing all the math and all the little lines and it doesn't work and you have to redo it. If you'll do a concept first, you will save yourself a huge amount of frustration, and in the end, you're going to save yourself about 90% of the time. It's going to go much faster. So please pay attention and pick up the ideas that we have here of how to develop a concept. So a couple of steps we're going to lead you through in developing a concept. They're really pretty straightforward. First, what is the design intent? You have to be able to think 3D. You have to envision what you want the landscape to look like. And to do that, you actually have to draw. Second, what is the desired water flow? Where do you want the water to go? And sometimes more importantly, where do you not want the water to go? So to do this, you're going to have to divide the site up into smaller units. And again, this is a drawing you're going to do. Then you're going to diagram the approximate landform and patterns. For example, are you going to have a contour here? Are you going to have sheet flow? You're going to look for these contour signatures because you're going to draw them out, look for transition areas and where things might be difficult. Then you're going to test key slopes using percentages and spots. And you're going to do these very roughly. You're going to check for the most critical areas and see if you can come up with slopes that are within the acceptable parameters. We're going to show you how to do this using very rough calculations. This is not detailed calculator work. This is very rough work, like using a chainsaw on a piece of wood. The reason it's important to do this is you're going to need to learn to explore and try out different concepts. But if the process of creating a concept takes you 3 or 4 hours, you are going to become very discouraged and not want to do this. So we're going to try to train you how to create a concept in maybe a half an hour. Eventually you'll be able to create these concepts in about 10 minutes. So bear with us as we go through this. It's going to save you a huge amount of trouble and it's going to make you a much better designer as you grow into it. So if you're given a site plan, some of the things you need to consider is what are the uses going on around the building and what sort of slopes would be appropriate. So for example, if you've got a terraced area here, you want that to be fairly flat. You want to play basketball in front of the house, then you're going to want something around a 2% slope. If you want to place in back to put play equipment and you want it to be visible from the window, again, you want to keep these slopes fairly gentle. Other areas on the side here, perhaps the slopes don't matter. And of course, you have trees that you have to protect and you have a property line you have to stay away from. All of these are part of developing a concept. You have to understand what it is that you want to achieve with the design. Second aspect of developing a concept is where do you want the water to go? Because on this site right now, all the water is running right down the center through the middle of your building. That is not where you want the water to go. You want the water to go around your building. So to do that, you're going to redirect water. You're going to create a swale that goes around the building and gets the water off to the sides, and then of course lets the water sheet flow down the front of the site. This is critical that you have some understanding that you're going to always have to have a swale around the back side of the building on the uphill side to get water to flow away. And of course, this is not a new concept to you. This is something we've shown you before. The idea of having a swale on the uphill side of the building to take water and direct it around the building to keep the structure dry. You're going to have this in every single design you do in one form or another. So for now, you can just sketch in a swale, to be truthful. You're going to say, all right, this is about where I want the swale, and that's how you're going to start this process. And then what you're going to do after you get that swale sketched in, and you understand the basic ideas, is you're going to have to go down to the road and you're going to have to see about how we're going to make a connection to the road. Because that road is one of the determining factors for the finished floor elevation of your building. And frankly, this finished floor elevation becomes the linchpin for your entire design. One of the things you're going to learn is that your finished floor elevation when you're doing concepts is going to have to be able to change. So in your previous assignments, we've given you the finished floor elevation. In this assignment, you have to determine what is the appropriate finished floor elevation for your design. And the easiest way to start that process is by starting with what you know, and you know the elevation at the road. You also know what are acceptable percentages for many different types of surfaces. So for example, if you're talking about a driveway, you're talking about a range that might be around 0.5 to 10% slope. That's a pretty well known that you can always start with. You also know how to calculate slope. We've given you these calculations in many different forms, so you will use these to make these calculations. But one of the things that we want to show you in this lecture is how to work faster by doing estimates. And one of the first keys to doing estimates is to understand slope. So here we've given you 4 example slope triangles, and they're actually very simple. They simply represent what is slope at a 1%. All it means is that for every 100 feet you go horizontally, you go 1 feet vertically. Likewise for 2%, for every 100 feet horizontally, 2 feet vertically, 5%, 100 feet horizontally, 5 feet vertically. You get the basic idea. But one of the things that's nice about these slope triangles that we're showing you is it always also breaks things up into smaller units. So if you only want to go 50 feet horizontally, you know you're going to be going up or down 2.5 feet. Likewise, if you only are going 10 feet horizontally, you know you're going to go up or down 0.5 feet. It's a very simple process to use. I advise that you actually print it out and keep it nearby. It's also a nice way to check and see if you're entering numbers into your calculator properly and or using the formula properly, because these slope elevations are fixed. These triangles simply do not change. And in truth, you can do a concept using just these 4 triangles, just these 4 slopes. Again, remember, this is a concept. It is not a final design. It's a concept. So you can use these to do a rough grading, a very rough grading of almost any site, so that you then have a safety net that you can come back and refine the site design as you go. So here's an example site we're going to use to help explain this process. And yes, you're going to have to go through all of these steps. You're going to have to remember to look at the analysis you just did. But the first thing you're going to do is you're going to set a trial slope for the driveway to figure out what are the possibilities for your FFE. Remember, these are the possibilities. You have to be flexible and you have to be willing to change it. We're going to talk about how you can do that. So to begin with, you start at the road. You have that information. You don't need to do an exact calculation right now because you're just doing a concept. You can start and say, all right, right here at the road, we're at 28 feet. And that's how we're going to start this process. So if you're starting at the road, we're going to make some assumptions here. We're going to say to begin with, we're going to do a quick measurement of this road. And in this drawing, it turns out that that driveway is 50 feet long. And if it wasn't exactly 50 feet, let's say it was 45 or maybe 55, we don't really care right now. We're doing a very rough estimate. So if we say that that's 50 feet long, we know what kind of change in elevation we're going to have from the 28 going up to the finished floor elevation for all three different trial slopes. So we can say, let's try the driveway at 2%, be a 1 foot change in elevation. Let's try it at 5%, be a 2.5 foot change in elevation. Let's try it at 10%, it'd be a 5 foot change in elevation. Now we're going to keep all three of these for now because we're not sure what we want yet. And all we're going to do is we're going to take that 28 and we're going to add the change in elevation to it to get the finished floor elevation. So what we're saying is that if this is 50 feet right here and we're going up 1 foot in elevation, 28 plus 1 foot is going to be 29, and that's going to be our finished floor elevation for 2%. For 5%, it'd be 30.5, and for 10%, it'd be 33 feet in elevation. So this is pretty simple. You've got three different possible finished floor elevations that we've just figured out, and none of them required a calculator. We simply used the triangles that we showed you. We went 50 feet and we added the difference in elevation from the start of the driveway to get a finished floor elevation. And now the question is, how are we going to choose which of these to use? Which one is best? Which one is worst? That's part of the process we're going to talk about right now. But first, I just want you to realize it was very easy to get three different finished floor elevations that we can now play with to see which one works best for us. So the next part of this concept is that we're going to figure out with these finished floor elevations, we have three different options, what would be the elevation for the high point of the swale. And like we did before, we're going to simplify this. We're going to say, all right, I remember you have to go down at least half a foot to get the spot elevation that's on the corner of the building. And if I go down another half a foot to the high point of the swale, I know I've got enough drop in elevation here. So for example, if this was 10-foot difference between the corner of the building and the location of the high point, that is your H is 10 foot, then going down with a V of 0.5 means you've got a 5% slope there. You could do it as a 2% slope if you wanted, that would be fine as well. But we're making this fairly simple right now. We're dropping down half a foot to the corner of the building and half a foot to the high point. That means that from the finished floor elevations, the three options that we have, all we have to do mathematically is subtract a foot from each one. So here you see the results. We had three different finished floor elevations. We now have three different possible high points of swale here. So that was actually very simple mathematically. You didn't have to pull out a calculator at all. This is simple addition and subtraction. We're adding to get up the driveway. We're subtracting to get down to the high point of the swale. And of course, now your logical question would be, all right, that's nice. We've got three different high points of swale, but how do I know which one I should be using? And the fact is, right now, you don't know which one you should be using. And so we're going to show you how to make some educated decisions here about which one to use. Now, you probably remember what a swale contour pattern looks like. And we're going to apply that swale contour pattern to our high point and our design that we have right now to help determine which high point of swale is going to work best for us. So let's start with the lowest one, 28. We got that one from 2%. The question is that something that's going to work for us? And again, if we remember our swale pattern, we know that there is a contour line that's going to come up and around nearly to that high point, or it might even touch that high point. So we're going to use the high point elevation that we have right now to sketch in a swale pattern. So if we go with the lowest high point, 1 from 2%, we get 28. That means that the 28 contour is going to have to be the first contour in the swale. And that is pulling up a really long way. And you can tell looking at this design, that's probably going to be a bit of a challenge. Now you're looking at that and saying, all right, that's a challenge. I don't know if that's good or bad because I haven't done this before. So we're going to do the other two, and then we're going to talk about how you're going to make that decision. Here we have the second high point elevation. And in this case, we have to pull that 29 contour up and around and then tie it back in. And we're like, all right, I can see that that might be good, it might be bad, I really don't know. Let's try the next one. And so the next one we're trying is the highest of the high points of the swale. This one is at 23. We have a 10% slope. I'm sorry, 32. We have a 10% slope on this driveway. Now, if we look at the 32 contour and we bring that up and around, that's starting to look a little more reasonable. So what we do is we go back and we look at these three different high points and how the contours might impact the design based upon those three different high points. And I hope you can see by looking at these three that the highest elevation of these three so far, that is the 32 elevations, is the best because the 32 contour is doing the least amount of damage. You may want to go back and go a little higher still. So you could go up and try it with the 33 contour. To do that, you'd have to increase the elevation of the finished floor for the building, and to do that, you would increase the slope of the driveway. What is really important for you to understand here is that this is not a complicated process. This is simple math based upon the fact that we say this is 50 feet, we round it to 50 feet, and we simply add whatever the difference in elevation would be to get different FFEs. Then we drop a foot down to the high point, and then we see what works in terms of the swales. The reason it's important to understand that is if you have difficulty with this, you're going to have to go back and repeat these steps. Repeating the steps, if it takes 2 hours, is so painful, you're never going to want to do any grading again. Understand that these steps that we just did should probably take you about 10 minutes. And so if you need to go back and try another concept, which is almost always a good idea, you're not going to spend hours and hours doing it. You are going to be using the same process now for figuring out if some of these trial slopes and elevations are going to work. So you're going to come from the side slopes, the back slopes, to see if you can fit these things in. And again, if it doesn't work, you have to keep going back and trying it again. And frankly, even if it does work, to be a good designer, you're going to want to go back and refine the process, refine the slopes until you get something that works as best as you can. I realize that right now you're thinking, hey, if it works, that's good enough. And you're right. For right now, that is. But as you develop in your design skills, you're going to use this iterative process in order to increase the quality of your design work. And again, we want to emphasize that the way to do this without spending hours and hours is to just rough it in. Just do a rough concept using just these 4 slopes for now. You can easily create other triangles and use them as well. We would advise that you do that. But the main point is we do not want you to spend hours and hours with your calculator trying to figure out the detail. That comes later. This is the concept stage. And of course, you're going to be asking yourself as you go through this, but what if it doesn't work? What if I've done all this and I cannot get it to work? The fact is, you can get it to work. You're simply going to go back and change some of the slopes, some of the elevations, some of the locations of things in your design. And what are the things that you can change? Well, remember, this connection to the road is really critical. You've got a range you can go here. You can go down to 2%. You could probably go up to 12 or 15% if you had to. I certainly wouldn't want to park my car in your driveway if that was the case. But there are a whole lot of things that you can change. And I've made a little list here. And this is not the all-inclusive list, but it's a fairly simple list. You can change the finished floor elevation. You can change how far away the swale is from the building. You could change the high point location along the swale if you wanted. You could change the elevation of the high point of the swale. You can change the slope in the swales. You can change the length of the swales. And of course, at the same time, that would probably change the low points of the swales. You can change the spots at the corners of the buildings. You have lots of things that you can change. What's really important is that you lose your fear of change. Change is going to make you a better designer, and the ability to make those changes easily is key to success in learning grading. So once you have some of these spot elevations and slopes established, and you've got at least one contour you like, you're going to want to go through and just start sketching in. Just start sketching in some of the other contours. Remembering, of course, that contours flow perpendicular to the water flow. So you use your basic knowledge about swale patterns to start to sketch these in. And of course, this is the basic contour pattern that you're going to use to represent a swale. So you're simply going to take this and apply it to your site. So in this way, you're going to get a rough idea of what this design is going to look like. Keep in mind that this is all part of the big picture. You need to understand how this site is going to work and what you're creating to make that work. So right up here, for example, you can see we've got some contours that look like they're running through some trees. That might be a bit of a problem. Here we have some contours that are too close to the property line. The question is, has the swale design that you've created forced that? And if so, what can you change? And if you want to know what you can change, go up a few slides and we've got a nice list of them for you. Again, that ability to change your design is something we need to make comfortable for you, and we will over time. So once you have these things resolved, this is a concept. It is still not a final design. It is not a final drawing. It is your safety net, so you can now go back in and work out the detail numbers with your calculator. Again, you don't want to work those details out to begin with. You want to work out a concept using the basic triangles that we've shown you. Then after you get something that works, you'll go back and create the final design. So those are the steps we want you to use for developing the concept. Next, we're going to talk about what you're going to do for the final design. Now for the final design, you're not going to use those triangles anymore. You're going to go in and calculate. You're going to actually recalculate starting all the way down the road to make sure that what you're doing is exact. One of the things that I always do is with my concepts, any spot elevations that I put in, I either only take them to 1 decimal point or I add a couple of question marks to remind myself this is just a concept. But in the final, I'm now going to go back in and refine those. I'm going to test different spot elevations and different slopes in greater detail to make sure that it works. So the process for testing and setting these spot elevations and slopes is not new to you. And as you work your way through it, these will become fixed elements. In other words, the road already is a fixed element. Now you've got a concept. You're going to do the calculations up to the garage, set your finished floor. That will be a fixed element now. You'll then work to the outside of the building, and the new calculations that you have for those spot elevations will become the next set of fixed elements. And you're going to work your way through this until all of these elements becomes set. This is the last part. You're still doing some trial elevations and checks, but as you find that they work and you refine them, now you go to double digits on your spot elevations, take away your question marks, and those become your permanent marks. As you're doing this, don't be afraid to make more changes. You're in the refinement state now. You're making sure that all of this works, and at this point, You can make small changes to this, and if you get lost, you simply go back to your concept and see what worked and see if you have violated that concept somehow. 90% of the time, it won't be an issue at all. Once you get to this point, it becomes a much more linear process. In fact, it can really become a rather boring process. As you're doing this refinement for your final, there are a couple of things you want to keep in mind, of course. The overall character of the landform, is it meeting the goals that you had in mind from the first couple of slides that we had? The type and desire of the slopes. Are they concave, convex? Do they create sheet flow? Do they create swales? The cross section of the swales. This is something you really need to check at this point. It's easy to forget to check how steep are the side slopes of the swales. And of course the cut and fill dynamics that we haven't talked about yet. But the idea is, are we bringing a lot of fill into the site, or are we creating a lot of extra fill that we're going to have to carry off? We'll be talking about that in later lectures. So as you're working through this, you're going to be resolving the flexible areas. They are going to become fixed areas. Always start with the most difficult ones first. You're going to proceed through and make sure that you have all of the ideas in the analysis satisfied. You're going to move through this trial and error process, but now you're not moving things a great deal. You're just resolving them in detail. Make sure that all your spot elevations are in place, corners, high points, low points, high point of swale, etc. Any place a material surface changes or there's a change in the slope. Add in all your contours. Do not add those too quickly. You can keep your conceptual contours in there. Your need to eventually delete those and put in the final contours, which are going to be determined mathematically of exactly where they cross the swale lines and exactly how far away from the building they need to be on all the corners. And of course, you have to finalize your drawing with your legends, your title blocks, all the spot elevations nice and neat. So these are all the steps you're going to need to undertake Project 1. Again, we advise that you revisit this lecture as you need to, and of course, we'll help you with this process. But I can tell you right now, if you're looking at this site, you know some things. You know what the elevations are. Actually, on your base plans, those elevations are deleted. You'll have to determine those. Work up to the driveway, put a swale around the backside, and see how that's going to work for you. Make sure that you are willing and able to try out different slopes so that you can try out different finished floor elevations and try out different slopes on your swales. The ability to refine the design during the concept stage is absolutely critical to being successful in grading landform.